Hey guys, it's Vince. Today in this video we are going to be discussing a question that was asked by a potential client, and it's an excellent question and I wanted to do a video on it because, again, this potential client, like many of you out there, are looking to do the right thing with your system, and you want to know when is an EMI filter the best use for this application with your robot. And it's a great question, and the actual question he asked was, I found an EMI filter on eBay. He sent me the link and he said, can I use this instead of using shielded cable to actually wire my limit switches? And he said that this is what the seller was saying. So of course I click on the link, I see the price on the board, I removed all of the information of the seller. I wanted to keep this as ambiguous as possible. Once again, it's a learning curve here. I want everybody to understand what we're looking at. And it says here, and again, this is what the seller's description is. Connect up to 4 limit switches to the left side of the board. It will output 4 clean signals. No shielded wires required. And he puts that in bold type. Regular wire works great. This is an excellent upgrade for any DIY CNC that uses limit switches. A common problem on CNC equipment, especially ones with spindle or stepper motors, is noise from the machine causing false triggers on limit switches. This is absolutely the most correct sentence in the entire listing. And that is absolutely true. Those false triggers are known as ghosting. Filter board is an easy solution to the problem. He states here, some limit switches bounce when changing position, creating noisy signals. Simply wire your limit switches directly to the board and connect them for clean wires, or connect the clean wires to your input circuitry. Finally, connect the positive 12 volt, positive 5 volt, and ground wires. All connections labeled for easy wiring, includes a 3D printed case and lid. Output clean is 0 to 5 volt depending on limit switch position. Okay, so after I seen this, and I could definitely see this potential client's confusion and anyone else that's read this. So what I wanted to do is clear the air and make sure everybody is extremely aware of when an EMI filter is best used. And not only best used, but I wanted to discuss it from an absolute expert in the field, which is Astrodyne TDI. For those of you not heard of Astrodyne, let's talk about them. They manufacture EMI filters. And Astrodyne TDI has been designing, developing, and providing high-quality EMI filters for a wide range of applications, including the commercial, industrial, medical, and military for more than 50 years. Their EMI filter solutions can help in improving the EMI performance of your device and in meeting the relevant EMC standards. So as we come over here, let me just scroll up. As we come over here, and we see here under EMI filter mounting tips. Now, of course, I will put a link here, so if you guys want to check out the best practices, you're more than welcome to. Astrodyne, like I said, I've used many of their products. They work amazingly well. Again, when used properly. The cables and wiring inside a system, including the input power cables, can act as an antenna for high-frequency noise. And again, it's breaking the megahertz up, radiating them through the air as well as picking them up. Now, again, guys, I've discussed this before numerous times. Most of you guys understand this, but I think what we're looking at here is just thinking in definition of an antenna. Whenever you're going away from a filtering device, that's exactly what's happening. Is the farther away we get from the filter, the less effective it becomes. And that's not just me saying it. We're going to go through it. So again, it's explaining here, radiating them through the air as well as picking them up. This can pose serious challenge for mitigating radiated as well as high-frequency conducted emissions. A higher frequency, and again, tens of megahertz and up, noise filtered by the filter circuit can couple back on the other side cables via the radiated mode. This makes the installation of the filter quite critical. Keeping the following EMI filter installation recommendations in mind can ensure proper EMI filter performance. Mount the filter in place that requires the shortest cable runs. Now, what you're going to notice is everything I've discussed about wiring and designing a system is built around basically these same tips. Whenever you're doing shielding of any kind, whether it be utilizing a filter or whether utilizing ferrites, I get questions on that all the time, and I'll be doing a video follow-up on that. You always want to keep the shortest possible cable runs possible. The shorter it is, the more filtered, again, that signal becomes. So again, very, very critical. On our systems, the better the engineering is with this, the more stable your platform for your robot will be. When the aim is noise mitigation, mount the filter as close to the EMI source as possible, whether it's a drive, uninterruptible power source, inverter, or another component. The farther it is, the more wiring is available for noise to propagate. Now, that one paragraph right there breaks up into showing exactly what we're talking about, with basically showing that this is not accurate on this system or whatever this board is. And again, somebody unfortunately already bought this. Thank God, I'm hoping they don't have any problems. But the misconception here is that for some reason someone is believing that they can filter at distance, and you cannot filter at a distance. And when I say a distance, it is a variable. And why I say that is because unless it's tested to a specific distance, we don't know the effect. And that's what these manufacturers do. They test at certain distances the effectiveness of what they're creating. Now, you can't see it here, but he actually put a picture here of what he claims as being a filtered signal. The issue is what is being filtered in terms of distance and in terms of duration. That's the difference between true engineering and saying, hey guys, look at this. This is what this is doing, but we're not defining it. Okay? In a follow-up video I will be doing on ferrites, because I get asked this question as well, why can't I use a ferrite instead of a shielded cable? It's the same principle. The longer the cable is, the least effective a ferrite is, because a ferrite is small. So unless you're planning on mounting multitudes of ferrites, which you've seen on my systems previously, where in a specific distance I stay within a range and mount the ferrites. And again, this is best practice, because ferrites, just like an EMI filter, they lose their effectiveness the longer the cable is. And we do not want the cable to simulate an antenna. And that's exactly what it is, whether it's a cable, whether it's a wire, whatever it may be. So when we see things like no shielded wires required, this is a great selling point. But I'm going to look at this from a completely logical perspective. Let's say we did not read what we just did here. Let's look at this from a completely logical perspective, and let's look at this from a commercial perspective. Think about how many filters would be used eliminating all shielded cable if all you had to do was mount an EMI filter. We would never be using shielded cable at all. So unfortunately, an EMI filter, once again, is best for isolated componentry. You'll see them being used on VFDs, very effective, as long as it's very close to the source, which is the VFD. Okay, you won't see it mounted 10 feet away from the VFD. You'll see it mounted directly by the VFD. So again, very, very powerful. For EMI compliance, install the filter as close to the point of power entry as possible. Once again, we can go right through this whole list. Bulkhead mount the filter to the chassis at the point of power entry with proper shielding, creating good input-output isolation. If bulkhead mounting is not possible, keep wires, cables at the filter input as short as possible and shield the input cables if necessary. On all of our equipment, it is necessary. And let me explain why. Okay? I've dealt with many clients that'll come to me, whether they're potential or even past clients, and they'll say, Vin, you know, honestly, if I'm a hobbyist, I don't need to buy the best cable. And I've heard this numerous times. I'm a hobbyist, I don't need to buy DS Flexion. I can buy, you know, whatever cable you have that'll work. Absolutely. I'll do my best to fit within your budget, fit within the MBR rating, so that, once again, we don't have premature cable failure once I know what we're dealing with. But here's what I won't do. I'm not going to blow smoke up anyone's butt. And when somebody tells me they're a hobbyist and says that, you know, because again, we're using the term hobbyist in the term that we don't need to use high-end components to build a robot, this is where we get convoluted again. Because the object here is stability. We're not worrying about your application. We're worrying about you having a robot that is able to be repetitive and function as a stable robot. If we do not implement the correct components to formulate that, then essentially you don't have a robot, and you'll have hit and miss occurs with ghosting and other issues. That is why your cable is essentially the heart of the machine. Think of it as the circulatory system of your robot. If those signals that are being sent, wherever they're being sent and carried all over that machine, if they are not stable and they have any type of interference, you're going to have problems. And it doesn't matter if it's on a $150,000 Haas or a Onefinity router at $2,000. It's the same principle. And the guy, once again, and I've used this analogy many times before, the guy, once again, cutting out a circle, whether it be on the high-end machine or, again, entry-level novice civilian-based equipment, if he cuts a circle out, he cuts a circle out, they both expect the circle to be round. They both expect the circle to be of the same geometry and the same dimensions that they programmed in. This is what you're paying for. So again, looking at this, studying it, understanding it, there is no way to break down the amount of knowledge all of these companies have. My goal here with the channel is to educate to where you guys understand. Unfortunately, some people's misconceptions of what they think they understand about hardware is completely false. And we've already proven this. And it's really scary to think that, again, as we read through this, and we'll keep going, let's look. For mill applications, again, that's military, use the mill-grade connector directly installed in the filter box and bulkhead mounted to the chassis. Over here, shield filter output cabling if it's picking noise from inside the system. Once again, it's kind of interesting how we keep kind of going back and forth where they keep bringing up, using shielded cable, using shielding techniques, and then, of course, using and integrating EMI filters where applicable. Route the cables away from the known noise sources in the system, they mean known. Mount the filter directly to a grounded bare metal panel whenever possible. The filter body acts as a ground, and mounting it directly to the ground plane saves ground wire runs and creates good low impedance EMI grounding. Now, guys, this is true to a point, but nothing is effective, especially on low voltage runs where we're dealing with 5-volt signals for most stepper applications. Most breakout boards are utilizing 5 volts. A ground bus bar is the most effective. So again, there are kind of, little twists and little adjustments we have to make for our applications. That's engineering. It's the way it is on everything. But the main thing here is that you understand, yes, EMI filters are super powerful devices. They work extremely well when put to the correct use. It's no different than selecting the proper screw for what you're trying to fasten. And the biggest misconception, again, is when we come over here where guys, once again, are under the illusion that we can provide a device to basically do away with using any type of filtering on any cable where we're carrying a signal at distance. This is a complete misconception. I naturally do not feel that this seller is intentionally trying to mislead people, but I do feel he shouldn't be selling something he doesn't understand. And I think many of you feel that way. And many of you, if you purchased this and had problems, you have every right to go back to him and question him. And I would recommend anybody, when he's posting things like, here's an unfiltered signal and here's a filtered signal, you should be asking him at what distance. The more detail you ask, you'll find out what's real and what isn't. If I go to Fairlight, who is a manufacturer of ferrites, we can go online. I'm going to do a video on it. It's super, super interesting to see where they actually test ferrites on different length leads to see what effectiveness they have, and they keep extending the lead to show the impedance difference. And that's what you guys need to understand. When you see this stuff done in more of a Mr. Wizard format, for those of you not old enough to know who he is, it used to be like a Mythbusters, so to speak, with different science projects. Super interesting to see when it's hands-on. Nothing is interesting in textbooks. I don't find that interesting. I like seeing real-world technology where it's actually being applied. Many of you like that. And again, this is what's going to define what's real and what isn't. This, once again, is a manufacturer. Fairlight is a manufacturer of ferrites. So we'll get to see it firsthand, not me telling you, me showing you. And in this way, you'll understand the whole principle and how effective cabling, once again, with proper shielding, proper grounding, will yield the most stable robot. And it does not matter if it's using a stepper, a closed loop unit. I hear that all the time. Well, a servo. Well, servos are better than it. Servo steppers, closed loop steppers, they're essentially all the same. They all require clean signals. It doesn't matter what it is. Okay? And the other perspective to think about, and I cannot emphasize this enough, you have a choice when building your system. You can do it right from the get-go and pay up front and say you know you did everything to the best of your ability. Or you could be in the point of corrective action all the time. And the choice is yours. In engineering, that's the best way to look at it. You're either going to be, hey, I'm going to test something and see if it works, great. The problem is when variables keep growing on the system you're working with, because, hey, I don't know if this works, 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 all of a sudden you get this giant list of variables. And if you're not documenting these variables and you don't know what to replace, what not to replace, that's where the headache begins. It's different if you've isolated a component and said, hey, I'm going to just change this one component, see what happens. That's when you learn something. And that's where, once again, we're starting to put the pieces together of formulating a proper robot. And that's where, again, it's very easy to get confused. So the big thing here, guys, is please take your time, ask the right questions. This video, I hope, is going to save somebody $40 because, again, we've just proven that I don't know what length this thing has been tested to. Many of you, I'm sure, don't know a length. He doesn't claim a length here. Ask. If you do stumble upon the listing, ask before purchasing. That's the only thing I would recommend. Again, is it feasible to think, and I'm going to be totally honest, that this unit will replace shielded cable? I think we've all seen that that's not the case. Shielded cable is designed for a purpose. It's not cheap. It's not meant to be cheap. But it will produce lots of money to a lot of robots. We rely on it every day. And not just, production robots. I want you to think in terms of medical use. A lot of guys don't think of, MRI machines. Everything on them machines are utilizing shielded cable. Where our cables for our computers, shielded cable. Why? I mean, we use ferrites with computers, but don't believe that those cables are still not shielded. And that's something always to think about. Always think about, where is this being used in real-world use? And why are we seeing it so predominantly used if we could just replace everything with a filter? A lot of your questions get answered that way. So again, I hope that this video has been helpful. I hope it's answered this question. I will once again do one on ferrites because, again, they are exceptional to be used, and it's just knowing when to do it, when not to do it, and that's the real critical side. So again, guys, if you have questions, require quotes, or consultations, you can message me direct at storm2313@gmail.com. That's my direct email. You'll see links in the beginning of the video, and of course at the end. You can also message me through my eBay store. Once again, guys, keep the questions coming. I do appreciate all your support. Thank you. Take care.